Hello everyone and welcome to this course on Numpy. So today in this video, I will be introducing you to the Numpy library in Python. Numpy is basically a very popular library in Python, which is used extensively for numerical computation, and it is a highly optimized library for that purpose. So these are the features of Numpy. It is easy to use. It is an open source library, and there are these things like linear algebra, statistical analysis, random number generation, and many more that you can do with NumPy. Now, the most important point here is that the code in NumPy is a lot faster as compared to regular Python code because the underlying implementation of NumPy is in the C language. So that is why it is a lot faster than regular Python code. So that's why NumPy is very popular. All right. Now, to show you this point that NumPy is highly efficient in terms of memory and speed, I have written this code. Here I have created two matrix basically. So this is M1 and this is M2. I have created them using the list. Basically, this is a nested list. So this is M1 and this is M2. M2. All right. Now, what I am expecting here, I have written here the code to basically multiply these two matrix M1 and M2 and give me the output. All right. So without wasting any time, let us run this code. So I created this matrix M1 and M2. Now using Python loops, I will generate the result. Basically what it does is it just multiplies these two matrix and gives us this resulting matrix. Fine, we are getting the output. Now I will import the NumPy library and create NumPy arrays A1 and A2 with the same list that we created earlier. And the difference here is that just that these are now NumPy arrays. So here I have written A1 at the A2. What it does simply is it multiplies both the matrix A1 and A2. You can see we are getting the same output in this as well. So the logic is, I think, correct in both Python loops and using NumPy. Now, the main difference come here when we use this same logic on larger arrays. So to do this, I will take the help of the time module. Now I will create the same A1 and A2, but this time the difference here is that the matrix is a lot bigger than the previous one. Here this time we have around some 10,000 rows and around 10 columns. So it has around 10,000 into 10, which is around 1 lakh values in this matrix. All right. Same with A2. Okay. So don't worry about the code. This is just to explain this is just to prove you that NumPy arrays are a lot faster than Python loops. We will see now. I will run this code, I think. Yes. So it took around 0.011 seconds to compute the matrix multiplication of these two matrix. All right. Now the same thing, but this time using Python list. So the same matrix A1 and A2 that I created here, I have created the list of both of them, and now I will use this nested Python loops to basically compute that resulting matrix that we get after matrix multiplication. All right. So let me run this now. So let us see. So the Python loops basically took around 1.603 seconds, which is a lot slower than NumPy arrays. All right. NumPy, if you remember, they took around yeah 0.011 seconds, and here it took around 1.603 seconds. So I think it is a lot faster, and this makes more sense now that uh, NumPy based algorithms are generally 10 to 100 times faster than pure Python, and they use significantly less memory. So this is the point that I wanted to prove you that why are we going to use NumPy for numerical computation. All right. Now let us see some. Okay, let us come to the course content now. So this is first video. This is the introduction video. In the next video, we will see how to create NumPy arrays, different ways of creating NumPy arrays, their basic attributes and methods that we are going to work with. In the second video, we will see basic indexing, slicing, and some arithmetics that you can do with NumPy arrays. This will be a very important video because here you will learn the indexing and slicing of NumPy arrays, which is very important. In the third video, we will see element-wise array operations on NumPy, and we will learn about broadcasting. All right. Then in the fourth video, we will see things like linear algebra, statistics, random number generation with NumPy. All right. And then in the fifth video, we will see some application examples in which we will use NumPy to solve those problems efficiently. All right. So this was course content. All right, now let's come to the prerequisite part. So there are a few things that you should be knowing before you start this course. This course expects that you have some basic knowledge of Python programming, like a little bit of experience, like you know what are integers, uh, a dictionary, Python list, all right. Then what are functions, all right. What are loops? So you should have written some codes in Python before, all right. Then you should also be familiar with some linear algebra and basic math, like you know what are vectors and arrays and like a matrix in mathematics if you have learned matrix. And then you should be willing to learn by practicing. I recommend that you also open a notebook with you and practice the code along with me. Okay. And you should also have this Jupyter and NumPy installed on your system. If not, then please do get this. Uh, I will recommend you that you can visit this website or you can watch some YouTube tutorial for the installation of Jupyter and NumPy. To do this, you will have to just use pip install Jupyter Lab in your command terminal. That's all. And to install NumPy, you will have to use pip install NumPy. That's it in your terminal. All right. So that's all. And one more very important thing that I want to show you before ending this video. Please visit this website called numpy.org. This is the official website of NumPy and the creators of NumPy is. So here you will see like you get a basic feel of what NumPy is. Here it says it's about full n-dimensional arrays. It's for numerical computing. It's a numerical computing tool. It's an open source. It's easy to use. We already discussed this. The most important thing that its performance, which is well optimized with C. All right, and we enjoy the flexibility of Python. All right. Then here, if you scroll down, you will see the domains in which NumPy library is used highly, like quantum computing, statistical computing, signal processing, image processing. Okay, so just get a feel of what NumPy can actually do. And one very important thing that I wanted to tell you is that uh, many libraries like PyTorch, TensorFlow, many libraries in machine learning like your sklearn, all right, sklearn, TensorFlow, SciPy, PyTorch. So these lot of the libraries like in machine learning and data visualization, they are built on top of NumPy. So I mean to say that they use NumPy in some way as their core data structure to work with the data. All right, so learning NumPy is very important from this perspective. So I think that's all for this video. And yeah, to check out this website and get a feel of it, you can see some case studies which just used NumPy in some way. If you have time, you can go through them. All right. So this is the end. And yeah, before one more thing I just forgot. Before going, let me give you a brief of what exactly the data structure that we are going to work in NumPy. They are also called as NumPy arrays. So we'll be working with 1D, 2D, and 3D NumPy arrays. So this is what a 1D NumPy array looks like. This is a 1D NumPy array. This is what a 2D NumPy array looks like a matrix, simply like a matrix. And this is a 3D NumPy array, like a collection of matrix. There are 3 matrix, 3 rows, and 3 columns. This is just a 2D matrix with 3 rows and 3 columns. All right. And this is just a one-dimensional array-like thing, like a simple list if you have seen in Python. All right. So that's it for this video. Thank you so much for watching, and I will see you in the next video. Till then, keep learning.